When we're looking for functional groups in organic chemistry, we're looking for anything that is not a carbon, single bonded to a hydrogen or another carbon. So what we're looking for is anything that could be considered a heteroatom, like this, or any pi bonds, like this. So this would be an alkene, and this is called a carboxylic acid. Here we have a carbon double bonded to an oxygen, and on either side we have other carbons. So this is called a ketone. This is called a benzene ring. When it's attached to something else, we call it phenyl. Here we have a halogen, and this is a bromine specifically, but you could call it a halide or a halogen. We do use them interchangeably, even though the suffix "ide" tends to refer to the ion. Here we have an ether. This is an oxygen that's single bonded to two other carbons. So this is an ether. This is another way to show an ether. Specifically, when you have a substituent that is an oxygen bonded to a parent chain, and then a substituent like this is specifically called methoxy. Similarly, if we had an ethyl group on that oxygen, that would be called ethoxy. This is a terminal functional group. You see the carbon double bonded to the oxygen, bonded to a hydrogen, and then on the other side we have the rest of the parent chain, and this is called an aldehyde. Here we have a double bond, so we would call that an alkene or a pi bond. And then rather than calling this an ether and then this a carbonyl compound, or a carbonyl group, they actually go together. And this is called an ester. So here we have another carbonyl carbon functional group, this time when it's bonded to an OH. This is a terminal functional group, so this is a carboxylic acid. And then over here on the ring, we have an oxygen single bonded to a carbon, and then it has a hydrogen. This is called an alcohol. Here we have an oxygen single bonded on both sides to carbons. This is an ether. And this is a special case ether, and we'll talk about these in Module 6. This is called an epoxide. Here we have a carbon double bonded to an oxygen, but on each side of that carbonyl carbon, we have other carbons. So this is called a ketone. This right here, this is a triple bonded. Now it's important to see there's a carbon here, there's a carbon at every end and bend. But when you have a pi bond like this, or two pi bonds like this, it's linear. So there is a carbon here and then a carbon here. So it's important not to lose sight of the fact that there is another carbon there. So this is a pi bond, or two pi bonds, and this is called an alkyne. Or we'll just call it an alkyne for now. We're not going to call it an or, call it anything else. So here we have a carbonyl carbon, and remember, whenever you see a carbonyl carbon, you have to look next door. So we have a carbon on one side, and we have an oxygen on the other. And because that oxygen is then bonded to another carbon, this is called an ester group. Here we have a pi bond, a double bond. This is called an alkene. Here we have a carbonyl carbon and oxygen group, I suppose. So a carbonyl group. And then next door, we have a carbon and a carbon. So because we have a carbon on either side, this is called a ketone. And here we have an oxygen that is single bonded to a carbon on both sides. This is called an ether. Here is another one of those special case ethers called an epoxide. And here we have a carbonyl carbon, but on one side we have a nitrogen group. This is a special case carbonyl compound, and this is called an amide, A-M-I-D-E, sometimes pronounced amide, but amide, depending on where you are in the country or world for that matter, you may hear either way. This is an aldehyde. Aldehyde is a terminal functional group. That means it's a carbonyl carbon, so an sp2 hybridized carbon, double bonded to an oxygen. And then on one side we have a hydrogen, and on the other side we have a carbon. Now we also have this chlorine group. A chlorine is a halogen. So you could be specific and call it chlorine or chloro or chloride, or just tell me it's a halogen. Here we have a nitrogen bonded to a chain as a substituent that's also bonded to an H and a CH3. Well, this is an amine. Amines are based on ammonia. Ammonia is NH3. You probably remember that from general chemistry. You just start substituting some of the H's for other things. So now we have an amine. And then we also have what's called a phenyl group, PHENYL, phenyl. That's where you have a benzene ring that's then bonded to something else. Now this one has a lot of carbonyl groups, but specifically we have to look at what is bonded to those sp2 carbons. So we have 3 different varieties of carbonyl compounds here. So let's start on the left. What I have circled on the left is a sp2 hybridized carbon, double bonded to an oxygen. That's what creates our carbonyl. On the left side of that sp2 hybridized carbon, we have an OH, and on the right side, we have a carbon that leads to the rest of the molecule. This one is a carboxylic acid. In the center here, we have a carbonyl carbon, an sp2 carbon double bonded to an oxygen. And then on either side of that sp2 hybridized carbon, we have other carbons. So that makes this one a ketone. Over here on the right, we have our carbonyl carbon, so it's an sp2 hybridized carbon and it's double bonded to an oxygen. And on the right-hand side, it's bonded to an oxygen that then has another carbon group. And on the left side, it's bonded to the carbon that's the rest of the molecule. This is the ester.